So now we worked with these unsigned numbers, but we also need to work with the signed numbers, right? Negative numbers as well. So we need to do some operations, additions, multiplications, divisions with these positive and negative numbers. Therefore, we need to represent the sign of the number as well, or the signed numbers in our system. So to represent them, we need to learn about the representation of the negative numbers as well. So let's start representation of negative or signed numbers. Let's say negative is not the right word. So in here we have three methods. We will see the first one is, it is easier for us to understand. The first technique is called signed magnitude representation. So there are different ways of representing signed numbers. The first method is signed magnitude. The second method is first complement representation. And the last one is two's complement. So we are using these three representation techniques to represent signed numbers, positive and negative numbers. So let's see how does signed magnitude is working. Right? Let's say signed magnitude representation. So if I give you plus 98 in base 10, right? So the sign here is positive and the magnitude of this number is 98. So if I tell you minus 57 in base 10, the sign is minus here, the magnitude is 57. So in the binary case, we need to represent this sign, right? Is either positive or negative. But I can only use 0 or 1 for the representation. So for 1 bit position, I will be using this for a sign bit. So 0 means it is a positive number and 1 means it's a negative number. And then I will be using other bits for the magnitude. Okay, so in this representation I have some bits to represent magnitude and one bit to represent sign bit. Okay, so always the leftmost bit is the sign bit. Okay, so in this representation in binary we can decide, or we can see if the number is positive or negative by looking the leftmost bit. If it is 1, we will say the number is negative. If it is 0, we will say the number is positive. So let's say I give 4 bits, 0, 1, 0, 1, and this is in binary, and I say this is in signed magnitude representation. So since this is given as the signed magnitude representation, I will be looking at the leftmost bit, right? I look at this and this is my sign bit. So since this is 0, I say this number is positive. And then this is the magnitude, and the magnitude is in this case 5. So this is positive 5 in decimal. So if I give you another number 1, 1, 0, 1 in binary, and I say this is in sign magnitude representation, so what you need to do, the first thing you do, you look at this position is my sign, the remaining bits are my magnitude. So this means this is a negative number and the magnitude is in this case 5. So this is minus 5 in decimal. Okay, so we can do many more examples, but basically it is just separating the sign bit and the magnitude and then converting them to decimal. So this was our first method. Now the second method is ones complement. So in the ones complement, I will start with an example right away and I will just tell you how to represent numbers. Let's say plus 3, and let's say I am using only 4 bits. So this will be again 0, 0, 1, 1, and plus 2, it will be 0, 0, 1, 0, plus 1, 0, 0, 0, 1, and 0, I will have all zeros. So to represent minus numbers, this is what we do. So this is the positive numbers. but in one's complement representation. To find out a negative number, what I do, I look at the positive number and I convert all the bits. So if I have 0001, then I will have 1, 1, 1, 0 for -1. Okay. So all I did is I flipped the bits on the positive side. Okay. So to represent -2, what I need to do, I need to go to the positive side. So this is my +2 and I flipped all the bits. So this will be 1, 1, 0, 1. So this is the -2 in one's complement representation. So let's say how I do -3. Again, I go and look at +3, which is here, and I invert all the numbers, all the bits, 1, 1, 0, 0. So this is the -3 in one's complement. As you see in the one's complement representation, the first thing we need to represent the positive numbers. Then to find the negative representations, we need to flip all the bits. Then we will be finding the negative representation. So let's do an example. Let's say I give you a number 1, 0, 0, 1. So this is, and I say this is in one's complement representation, and I would like to know what is this number in decimal. Okay. So the first thing that you need to notice, the negative number is always has 1 on the leftmost bit. So from this, you can tell this is a negative number. But what is the magnitude? We don't know the magnitude because this is not a signed magnitude that I cannot easily find out the magnitude. So to find out the magnitude, what I need to do, convert it to positive, and then from the positive number I can tell the magnitude. So to find out the magnitude of a negative one's complement number, we need to first take the number and convert it to positive, and from the positive side we can find out the magnitude. So the number is given 001. So I know this is a negative number. So to find out the magnitude, I need to convert it to positive. So I take one's complement, I complement all the bits or invert all the bits. So what is this? This is positive 6, right? So this is the magnitude and it is 6. So if this is positive 6, then this number, the magnitude is 6. So the number is -6. So this is how you can determine the number in one's complement. So if the number is negative, you need to convert it to positive by complementing, and then you find the magnitude, and you already know the sign from here, and then you will say it is -6. So let's do one more example. So let's say I give you another number with 8 bits in this case. So this is in binary and this is in one's complement representation. So what is this number in decimal? So the first thing that I need to do, so I look at the leftmost bit. So from this, I know this is a positive number. If this is a positive number, finding out the magnitude easy. I can directly look at here and I can find out the magnitude. So in this case, magnitude is 1, 2, 4, 8 and 16. So this is the weights, right? So the magnitude is 16 plus 4 plus 2. So this is 22. So the number is plus 22 in decimal, right? So this was the example for a positive number in a one's complement representation. So let's look at two's complement representation. This is the representation which is used by most digital systems. So from now on, we will be always using two's complement representation for the signed numbers. Again, I will directly start with giving examples representing numbers using in two's complement. So let's see what is the representations of these numbers in two's complement. So assume we have 4 bits. So to represent plus 3, I will be having this 0011. So this is the plus 3 in two's complement representation. This is plus 2. This is plus 1 in two's complement. So this is 0. And for minus 1, it is similar to one's complement representation. To find out the representation of minus 1, I first look at plus plus 1 and then I take 2's complement. So taking 2's complement means invert all bits then add 1. Okay, so it means I take 0 0 0 1 and I first take the complement of the bit, I flip all the bits, then after that I add 1 to it. So 0 0 0 1 in this case, and this is I inverted all the bits, then I add 1 to it, so I will get 1 1 1 1. So this is the negative representation of 1, which is minus 1 in 2's complement. Okay, let's find the representation of minus 2. So to find the representation of minus 2, I first find plus 2 and then I need to take 2's complement. So how do I take 2's complement? I first take the number 0 0 1 0. I invert all the bits. So this is also equal to 1's complement. I take 1's complement. Then for 2's complement I add a 1 here. So it will be 0 1 1 1. So the representation of minus 2 in 2's complement is 1 1 1 0. So this is minus 2. Okay. So similarly, let's do minus 3. To find out minus 3, I first look at plus 3 and I take 2's complement of plus 3. So this is plus 3, then I invert all the bits. I got 1 1 0 0. Then I add a 1 to it. So I will get 1 1 0 1. So this is my representation of minus 3 in 2's complement. So let's summarize. Given the decimal number, so this is, let's say, plus 3, plus 2, plus 1, 0, minus 1, minus 2, and minus 3. So we have three different ways of representing sign numbers. The first one is sign magnitude, and then 1's complement, and then 2's complement. So in the sign magnitude, so I will have 0, 0, 1, 1 for plus 3. For plus 3, I have 0, 0, 1, 1 in 1's complement, and for 2's complement, I have 0, 0, 1, 1. So actually, the positive number representations are the same in these three methods, and plus 1 and 0. So for sign magnitude, I have, this is positive 0 and I have also negative 0, but this is only for the sign magnitude. So this is negative 0, this is positive 0. But for 1's complement, I have all zeros and all zeros. So for minus 1, for in the sign magnitude, I put 1 here, so this is my sign, and the magnitude is 1. So this is minus 1. For minus 2, so this is minus, so the magnitude is 2. So this is minus, and the magnitude is 3. But for 1's complement, to find minus 1, I just take this plus 1, I invert all the bits. So this will be 1, 1, 1, 0. And for minus 2, I look at positive 2 and I put 1, 1, 0, 1. I invert all the bits. For minus 3, it is 1, 1, 0, 0. So for 2's complement, for minus 1, I invert all the bits of plus 1 and then I add 1 to it, right? So this will be 1, 1, 1, 0, and if I add 1, it will be 1, 1, 1 and 1, right? Because I am adding 1 to it. For minus 2, it will be 1, 1, 1, 0. For minus 3, it will be 1, 1, 0, 1, right? So as you see, the negative number representations are different. But if you look at the positive side, they are the same in three representations. So let's do an example so that you might understand it better. So we will say express plus 19 and minus 19 using 8 bits. So we need to use 8 bits in sign magnitude, 1's complement and 2's complement representations. So plus 19, so this is decimal. In signed magnitude, we need to use 8 bits, right? 6, 7, 8. So sign is 0 and I need to have 19. So this is 3 and I need 16. So this will be plus 19 in sign magnitude. And in 1's complement, I will have the same thing, 0, 0, 1. 0, 0, 1, 1. And in 2's complement, it is the same, right? Positive numbers representations are the same in three representation. And then let's look at minus 19. So in sign magnitude, I know this is my sign bit, this is 1, but the magnitude is 19. So this is in sign magnitude representation. In ones complement, I look at the positive. So this is my positive 19, and negative 19 is, I just invert all the bits. And in twos complement, I look at the positive and then invert all the bits and add 1 to it. So I will have 1 1 1 0 1 1 0 1. So what do you see is twos complement is equal to ones complement plus 1. As you see, if you know the ones complement of a negative number, then you add 1 to it, then you will get positive. For this is for the negative numbers, right? So twos complement representation is ones complement representation plus 1. Don't forget, this is for the negative numbers. Okay, let's do one more example. So I will say determine the decimal value of this number 1 1 1 0 1 1 0 0. So what is the decimal value of this number? So when I ask this, you should be asking me in which representation is this number is represented. So the question is missing in what representation this number is given. So then I will say this number is represented, because if I don't say, you cannot determine the decimal number, in twos complement. So this number is given in twos complement representation, and we need to know the decimal equivalent number for this representation. So the first thing I need to make sure, so what is the sign of this number? Is this a positive number or negative number? I look at the leftmost bit, so this is a negative number, right? So this is negative. But then what is the magnitude? To find out the magnitude, I need to take twos complement. So there are two things. One is twos complement representation, the other one is taking twos complement. So taking twos complement means invert all the bits, then add 1. So I will be inverting all the bits 0 0 0 1 0 0 1 1. Then I need to add 1 to this. So I will get 0 0 1 0 1 0 0 0. So what is the magnitude here? This is 4. This is 16, right? Then we will get 20. So the number was minus 20. Let me make sure I did it correctly. So I inverted all the bits 0 0 0 1 0 0 1 1. Then I add 1 to it 0, and then I have a carry of 1 1 1 0 1. So this is 20, right? Okay. So let's do one more example. So given this number 1 1 1 0 1 0 0 0. So this is given in sign magnitude representation. So what is the number in decimal? So since this is a sign magnitude representation, in the sign magnitude representation, this tells me the sign. So this is minus, and this is my magnitude. So this is 8, this is 32, this is 64. So this is, if you add it, the number is minus 104 in decimal. So let's see, I give you a number again. So this is 8 bits and all ones, and I say this is in ones complement representation. So what is the decimal value of this? So here what we need to do, again, by looking at here, I know this is a negative number, but I don't know the magnitude. To find out the magnitude, I need to invert all these bits. In a way, I need to take ones complement. So this is my magnitude. The magnitude is 0. So the number is minus 0 in decimal.